So in the previous video we talked about three concepts, and those concepts is help you to understand better the concept of probability. The concept we discussed last time in the previous video was concept of suddenly I just forgot to counting principle, right? Permutation and combination. And you will see in this chapter we're gonna use those concepts to find probability. However, in this video, okay, we'll be discussing the definition of the basic probability first, which is um, the whole chapter is about. Then in the next few video, let's see we can use the permutation and combination and counting principle to calculate the probability, which is the sum problem, which is harder than the basic one. Okay, so let's get started. So I'm gonna put over here the title for today is a probability. Probability. Okay. Um, Before we talk about the definition of probabilities, I would like to talk about some terminologies, and you need to have some knowledge of this terminology so that you can understand better the definition of probabilities. Okay. Um, the first definition I want to discuss, the first terminology here, it is the first one. It is called experiment. Okay, we need to know what experiment means. I'm not talking about the chemical experiment or physical experiment. Okay, so the experiment in mathematics, especially in the concept of probability, it is just the operation is a control operation. Okay, okay, that you a set of result that you a set of result. Okay, so the experiment is just the operation, the performance. Okay, for example, like you throw a dice, you pick up a ball in the bag, or uh, you counting numbers, or any operation you can call it experiment. Okay, the second terminology is the sample space. Sample space. So the sample space is actually the set of all possible outcome. The set of all possible outcomes. Okay. So the outcome is just the possible result. Okay. So outcome here is just possible result in the experiment. Okay. So sample set it's a collection of all the outcomes Okay. And the third one is the event. So the event is subset. It's a subset of it's a subset. It's a subset of sample space. Okay. And most of the time we use letter E to represent event. Okay. Alright. So this terminology here is to help you understand when you read the question. Okay. Because when we do probability, it's like you solving word problem. Of course, you have to understand the word. You need to understand the question first. So this is like your vocabulary. Okay, you understand the scenario before you can calculate the probability. And probability I talk about in this video, there are two different types probability. So on the first Roman, I want to talk about the theoretical probability. Okay, theoretical probability. Okay. Okay. So then, so what is theoretical probability? So theoretical probability of the event. Okay. So every time we talk about it, we talk about the probability of the event. Okay. And we can use the following formula here to calculate the theoretical probability. Okay. So P of E, which is the probability of event E, is the ratio between okay, this is ratio of the favorite the ratio between a favorite outcome. Okay, a favorite outcome over the total number of outcome. Okay, over the total number of outcome. Okay. So the total number of outcome over here is just the sample space. So their favorite outcome is actually the event, the subset of the sample space, of the sample space, the subset of the sample space. Okay. So the favorite outcome, which the outcomes, the subset that you want. Okay, you want. So that's a formula to calculate the theoretical probability. All right. Now we can jump to the first example right away. Let's see. Example number 1. All right, so I have something like this. Okay, checkpoint number 1. Okay. Now, as a dice, and the dice, we roll a dice once and find the probability of rolling number 2. Okay. So we know that. A dice has totally 6 faces. Okay, 1, 2, 3, 4, 5, 6. So the sample space in our case is 1, 2, 3, 4, 5, 6. Okay. Now question number A, they ask you to find the probability of getting number 2. So the event over here is a subset of the sample space. In this case, is the event is 2. So we know the totals, the sample space. We know the element of in the event. So we can find the probability. Okay, so it could be there's only one element in the events set. However, there's 6 elements in the sample space set. So we 1 over 6. Okay. So that's what it is. Okay. Now for question number B, now the events set is different. So the event set now is not 2, but any number less than 4. So it could be 1, 2, 3. So there are 3 elements in the event. So we can find the probability of this event will be 6. So it will be 3 over 6. 3 elements in the event and 6 elements in the sample space. So it will be 1 over 2. Okay. Okay, and for part C, the E is different now. E is even is just any number greater than 7. But the dice we have only 1, 2, 3, 4, 5, 6. So we can get the probability of a number greater than 6 will be 0, right? Because there's no number actually. There's no number greater than 7 in the dice. And for part D, the event now, let's see how many, a number less than 7. So it'll be 1, 2, 3, 4, 5, 6. Okay, then the probability for this event will be 6 over 6. So the probability will be 1. Alright, so what we know out of this? So we know that you see that over here, 1 over 6 is a number less than 1. 1 over 2 also a number less than 1. This 0 is definitely less than 1. So if the sample space and the event set had the same number of elements, you see the probability will be 1, which is the largest probability value you can get. Okay, you're not going to get a probability that's greater than 1. No way you're going to get like that. Okay, so out of this example, we can put the first remark over here is that the probability of the event, okay, is always less than equal 1. Okay, so we're not gonna have a probability like 1.5. That doesn't make sense. Okay, so the probability is always less than equal to 1. All right. Now let's do another example. Now I want to maybe after you finish the first example, you still don't know what theoretical probability is. Theoretical probability is just the probability in theory. What does it mean over here? That if you notice in the first example over here, it say a die is rolled once. Okay, and even sometimes the question it didn't say that. It didn't say anything about dice being rolled or not. It didn't say anything about that. It just say find the probability of getting number 2 in a die. So the theoretical probability this does not depend on how many performance you have. Okay, because and you see that in the first example, it never mentioned that, okay, the die is rolled how many times. Okay, when they talk about the number of operation or the number of performance to get a favorite outcome, then that's not theoretical probability in them. Okay, other than that, all the question will be theoretical probability. Now some professor want to talk about the other probability first, which is on the second part of our lecture. But I want to talk about theoretical probabilities first, because as long as you understand the theoretical probability, you can do the other type of probability easily, which is again I'm going to talk about the name of the probability in the second part. Okay, I don't want to mention the name right now. Now in the second example, problem like this. Okay. So I have a standard deck of playing cards like this, and it should have 13 cards. So you see that we have 13 cards over here. We have heart, club, diamond, spade, 1 to 10, and 3 face cards. Face card is jack, king, queen. Okay, and we totally have 12 face cards. So we have for jack, for queen, for king. Now the question is find the probability of drawing the card. Find the probability that the card draw is, okay, I need to change a little bit over here. Let's say I want to draw a card 7. Okay, 7. Okay, and over here not a 7. Over here for part C, I want to get a diamond card. Okay. This is over here. I want to have a card greater than 6 and less than 9. Okay. So let's see how we do this with this one. Okay. All right. So again, this one is theoretical probability, because you see that we never mentioned about how many operation with this, like how many times we draw number 7. Okay, I never mentioned about that, and it never mentioned about that how many card deck we have. So they just say a standard card deck. Okay, and they didn't say how many times we draw number 7. So this one definitely the theoretical probability. Okay, okay. All the information we have over here is the characteristic of the card, right? We never changed anything about this card. So this is the standard card. Nothing changed over here. Okay, because if it is the another type of probability, they probably said, okay, instead of considering 4 jack, 4 queen, and 5 king, they just add something else. Okay, they changed. Okay. All right, so let's see how we're gonna get the probability of 7 over here. So we have 7 king. So totally we have 52 of them, right? Okay, so we know the sample space. The sample space, there are 52 elements. Okay, so the cardinality of the sample space set has 52 elements. Okay, however, the favorite outcome, the cardinality of the event is 7, so there are only 4 elements, because we have 7 heart, 7 spade. Okay, we have 7 club, we have 7 diamonds, so there are only 4 elements here. So from here we can calculate the probability of the event will be 4 over 52, which is 1 over 30. Okay. B. Now not a 7. So let's see how many elements in the events set over here. Not 7. So we have 52, and we subtract by 4, so we have 48. So there are 48 elements. That is not they're not 7. So we have probability here will be 48 over 52, which is 12 over 13. And you see that all the probability at this moment is all of them is less than 1. Okay, theoretically it's always less than equal 1. All right, for C, the diamond. Okay, the diamond. How many diamond we have over here? We have 13 car of diamond, so we have 13 element. All right, so the probability over here will be 13 over 52, which is 1 over 4. It's also less than 1, right? Now D, probability, the cardinality of the event set on a jack or queen or king. So there are totally 12 of them. So we here 12. So we're gonna have probability go here, go be 12, 52, which is 3 over 13. And E are hard or spade. So let's see how many hard or how many spade. So we have 13 hearts, 13 special, 26 element. Okay, so the probability of it will be 26 over 52, which is heart. Oh, this is heart and spade. This is heart and spade. We don't have heart and spade, right? I'm sorry. If the question is heart or spade, then we have 26. So we don't have any card that contain heart and spade. Okay, in one card, so we don't have something. So this one, this should be 0, guys. Be careful. Okay, so this should be 0. So there's 0 here. So we have 0 probability. We never have any chance of getting a card that has spade and heart at the same time. And finally we have absolutely a card greater than 6 and less than 9. So greater than 6, less than 9, we're gonna have one of them here. And so we have 7, 8. 7, 8 for the heart, 7, 8 for the club, 7, 8 for the diamond, 7, 8 for the special. Totally we have 8 of them. Okay. Alright, so we have the probability here will be 8 of 52, which is 2 over 13. Okay. Good. Okay. Now I want to mention over here, if you based on this example, I want to draw a secondary mark. So you see the probability of getting 7 is 1 over 13, and the probability of not getting 7 is 12 over 13. So if you add these two fractions, they give you 13 over 13, which is 1. So based on the answer of question A and B, I can jump into the secondary mark there. Okay, the secondary mark is the probability of the event plus a probability of not an event. Okay, not that event. Then this one, it turned out to be 1 all the time. Look at this, see that? 1 over 13 plus 12 over 13 give you 13 over 13, which is 1. This is very important remark, okay? A probability of getting an event plus a probability not in that event is equal to 1. Okay. Now let's see if we can do another example. Okay. Number 3. Okay, example number 3. No, and the probability. I have a picture like this. Okay. So you see that this is the theoretical probability, because you see that they didn't say how many times we turn the spinner. Okay, we don't know how many times we turn the spinner. They just say that the spinner length. Okay, so if they say that the number of performance, the number of time you guys turn the spinner, then it's not a theoretical probability anymore. Actually, it's called an empirical probability, which is again the second part I will talk about. Now for this one, let's see how we do that. Okay, we're going to be talking about we need to know the cardinality of the sample space. So we have 1, 2, 3, 4, 5. So totally we have 10. Okay, now we're gonna find the probability, cardinality of event, which is indicate the red region. So we have 3. Okay, so from here we can get probability of the event could be 3 over 10. Okay, right? Pretty easy, huh? 3 over 10. Now, in order to get the blue, so this is the first question. This is A. This is B, C, D, E. So question B, get a blue region, so probably the cardinality of the blue set, so there's only 2. So the probability over here will be 2 over 10, 1/5. And for cardinality of a region is red or blue. Okay, let's see how many elements red or blue. 1, 2, 3 red, 2, so will be totally 5. Region probability of getting red or blue will be 5 over 10, 1 over 2. And for part A, the cardinality of the event with yellow. So how many yellow? 1, 2 yellow. Okay, so the probability over here for this event will be 2 over 10. Okay, and finally the cardinality of getting the brown, so we get 1, 2, 3 brown. Okay, so the probability over here will be 3 over 10. Okay, pretty easy. Okay, let's see I have another one or not. If not, I believe that this should be okay enough. Okay, so we have, okay, so I think that's good enough. Okay, all right. Now on the second part of our video here, and the second type of probability we call the empirical probability. Okay, which is the real probability. Okay, so this probability you have to take into the consideration the number of performance over here. Okay, and the formula to calculate the empirical probability will be as follows. So P of E will be equal to, so we have the ratio. Okay, the ratio, the number of times the event is has occurred. The number of time event E has occurred, and over the total number of time the experiment has been performed. The number of time the experiment has been performed. You see that? So we put into consideration the number of the performance. Okay. Last time we just talked about the number of the sample space, the number of elements in the sample space in the bottom. But now we need to talk about the total number of experiments performed. Okay. All right. Now let me start the first example here. I had a problem like this. So a coin is tossed 100 times. So it's not just a coin, okay, but this coin is tossed 100 times, 44 landed heads up. Okay, so you know the coin has only tail and head. Okay, but out of 44 times, out of 100 times they toss, the 44 of them we have heads up. Determine the probability of the coin landing heads up. Determine probability of the coin landing heads up. Now, if you read the question, you will see that they didn't say determine the empirical probability, but it's your job to figure out what kind of probability we are doing over here, theoretical probability or empirical probability. And in this case, the question is tell you that this is empirical probability because you see that the number of time experiment performed, right? Okay. If it is theoretical probability, they just say, okay, a coin tosses a coin, okay, and how many times you get a head up, something like that. But now we have tossing 100 times. So the probability in this case will be, so we have probability here, which is the number of event occurs over here. So we have 44 times it occur over 100 times, which is the number of times experiment performs. So you're gonna end up with 44 over 100, which is 0.44, which is 44%. If you want to convert it to the percentage, and you see that it's all again is also less than equal to 1. It's never greater than 1. Okay. it probably end up with 1 if we toss it many times, which is on the second example right here. In the second example over here, we talk about law. Okay, law of large number. And large number state that if the experiment is performed many times, then at the end the theoretical probability to become the empirical probability will become theoretical probability. Okay, now I want you to look at this one right here. So let's say that instead of tossing 100 times, we toss 1,000 times, 10,000 times, 100,000 times. Okay, and you see that the more you toss, the number of heads up you have will be increasing. Okay, and you see that this is the observed one. Observe the actual situation. This is what we expect because there's only head and tail. There's only the coin is only head and tail. So if you toss 100,000 times, actually 500 of them will be head, and the other 5 will be tail. But what it turned out to be is only 546. The reality. This is the reality. And so you see that if you take this and you set it over the number of times the experiment has been performed, which is 1,000, so you can see that the number is increasing, and it keep increasing when you toss like 100,000 times. You see they get closer and they get closer and it get closer to the theoretical probability. It get closer to the theoretical probability. And because theoretical probability is what is theoretical probability over here? We know that the sample space is just head and tail, and we know that in order to get a head, so the event has only head. There's only one element, so the theoretical probability in this case is actually 1 over 2, right? So the more you see the more you toss the coin, the more you get closer to the theoretical probability. Okay, you get closer and closer. Actually, over here is already reached the theoretical probability, but you will see it's even clearly that something that you put 1 million over here, it get really close to 0.5, really close to 0.5. Okay, so that's the reason why I talk about the theoretical probability before we talk about the empirical probability, because the empirical probability is just a probability reflecting the real situation. Okay, theoretical probability is just in theory. Okay, now let's uh let's see, we can have another example over here so that you can understand better. uh do I have it here or not? I believe I have another empirical probability. Okay, okay. So I have the information like this. Another trick you can take to help you see, to tell the difference between the theoretical probability and the empirical probability. And most of the time, the empirical probability, the question is it contains the table. It gives you the data, the table of data. Okay, so we know right here this is must be empirical probability. Okay, so let's see how we're gonna do this. Put this is question A, B, C, D. Okay, so this is question A, B, C, D. Answer. All right, so five probability is when the random select from age 20 or over, 25 or 25 years of age or over. And this column over here tell you the less than 4-year high school, 4-year high school only, college or more total, and this is information about male and female data and the total. Alright, question A, what a probability that has less than 4-year high school. So let's look at this one right here. So we know that less than 4 years of high school, including male and female, which is 35. So the probability in this case will be 35 over the total, right? The total will be 156. Okay. Okay, so this will be give you the probability of part A. I don't think we can simplify this, so I'm gonna go ahead and convert into decimal number. It's about 22.4%, so it's 0.224. So you see that it's less than 1. Okay, how about part B? Part B over here has 4-year of high school. Only 4-year high school, this will be 52. 52 over 156. Okay, 52 over 156. About 1 over 3. Okay, simplify that. And part C is a female with 4-year college or more. So this is 4-year college or more. So female is 21 over over 156. Okay, which is simplified, will be 7 over 52. And finally, we want to find probability of 4-year college or more. 4-year college or more male, so it will be 23. 23 over 156, which is about 14.7%. Okay, yeah. So that is the trick I give you to the difference between theoretical, to recognize which one is realize which one is theoretical probability and empirical probability. But you see that in general, probability is just a ratio between what we want and the total that probably the total outcome. Okay, what we want over the total outcome. Okay, and again, most empirical probability they have the data table like this. Okay. All right, so I'm gonna stop the lecture over here. I think you have enough example. Again, in order to be good at probability, you have to practice a lot. I don't think it's a hard concept, but this video over here is like the basic knowledge of probability, because later on we're going to use the concept of intersection and union. You remember we talked about set and logic in at the beginning of the semester. We're going to use that to calculate some more challenging probability problem. Okay. All right, I'm going to stop over here. I'll be seeing you next time.